Okay, so hi there, everybody. We're going to continue with our batch of videos in grade 11 statistics and probability. In this video, we're going to go back in combinations in example 14. Since in the last video, I haven't really given you a detailed and an illustrated one on how to answer that problem. So we're going to go back there and answer that in illustrations and with complete solutions this time. Okay, so if you have your calculators there, I think it's better to have it at handy. I have mine here. I cannot show it here. So anyways, let's get into it. So example 14 tells us of a 10-person committee is to be selected out of 15 equally capable candidates. So letter A asks us, in how many ways can this be done? Sorry, I think there should be a word here, can. Okay, can this be done if there are no restrictions? So anyone can choose or can be selected from these 15 um, individuals, and we only need a 10-person committee. So again, in a committee, combinations doesn't really um, mean that there is an arrangement or there is a rank, but a committee is just composed of a 10 persons from this 15 one. So there is no order that we need to take into. Okay, so there's no order, so we only need to choose or select 10 persons out of 15. So we're going to make use of combinations. This is surely combinations, and we will say that this is our total number, this is our n, and this is our R. This is what we want to arrange, or not, this is what we want to choose or select from this n total objects. So we say that our n is equal to 50, or sorry, 15, I mean, and our R is equal to 10. So we're going to say in the notation of combinations. So we will have 15 choose 10. Okay, 15 choose 10. Okay, so remember our formula for combinations. I think I can write it here. Where? Here. So we have n choose r. Oh, sorry, we don't need a bar. N choose r is equal to n factorial all over r factorial times the quantity of n minus r quantity factorial. So we're going to follow it here. So what we have is, our n is 15. So what we have is 15 factorial all over 10 factorial times the quantity of 15 minus 10 factorial. That's going to be 5. Okay. Now let's simplify our denominator. So what we have is 15 factorial all over 10 factorial times 5 factorial. So 15 minus 10 is 5, right? Let's try and get onto it. We can still simplify. So our numerator can run like 15 times 14 times 13 times 12 times 11 times 10 factorial. Okay, and then 10 factorial means, 9 times 8 times 7 times 6 times 5. We can think of this as 10 factorial here. And notice we can cancel up this 10 factorial in the denominator with the 10 factorial in the numerator. Okay, and then we are left with 5 factorial. So I think we need to spell that out. So what we have is 5 times 4 times 3, um, 3 times 2. I think we don't need to write the 1, right? Okay, so times 2. Okay, we can cancel up things from here. We know that 5 times 3 is 15, so we will cancel 5 and 3 here with the 15 above. 4 times 2 is 8. Maybe we can cancel 4 by 12. That's gonna give us, 4 will become 2, 12 will become 6, right? 12 will become 6. We can cancel further 2 here, or sorry, well, we can divide this by 3. Okay, sorry about that. That's not the greatest common factor. Anyways, we can still cancel the 2 here and cancel it with our 14 above. Okay, and that's gonna give us 7. And what is left with us? We are left with these 7 times 13 times 3 times 11. So what we have is 7 times 13 times 3 times 11. Okay, so that is the number that we want to multiply with. Um, Maybe we can use our calculator with that. It's quite a big sum. So what is that? 7 times 13 times 3 times 11 is gonna give us 3003. So let's write it down. 3000. Okay, so there are 3003 ways in for you to choose a 10% committee out of 15. So actually, if you have your scientific calculator there, you can just, find the NCR, and finding the NCR, what you will type is 15 NCR 13. So yeah, 15 NCR 10 rather. So that's gonna give us 3003. You can check that in your and in any of your scientific calculators if you're using a TI calculator. So you will just find the NCR there. I cannot say for everything for all the calculators since each calculator, each brand has a different um, placement of where the combinatorics is found. So just find the NCR in your own calculator. So the answer is 3003. 3003. Okay, so there are 3003 ways. Okay, let's move on into the next number. There's a second number actually. This is our second number. Okay, so let me read this first. Suppose we know that 9 of the candidates are female. If we wish our committee to be equally represented for both genders, how many committees are possible? So meaning there's a committee of composed of males and a committee, or rather, this committee is composed of males and females, which are equally represented. So remember that we want a 10% committee. So if it's a 10% committee, 5 would be males and 5 would be females. So let's have the givens first. We have 9 here. 9 is the number of females. So let's have it first. Our n, remember, our n is equal to 15. There are a total of 15 individuals, and we only want an r of 10, a 10% committee. So from our n, let's call it, what do you want? N of females is equal to 9. So by complementation, if 9 are females, the number of males would be, 15 minus 9 is 6. So there are 6 males. We want a committee of which is equally represented. So our R for the females, we would want to choose 5 from the females, and we also want to choose um, 5 from the males. Okay, so that's how we look at our composition. Okay, now we want to choose 5 from the females first, and then we're going to choose 5 from the males. And what we're going to do is to combine these the ones that we chose. Okay, and then we're going to put that in a 10% committee. Now let's take into consideration first the females. So we'll have let's denote females as F. Okay, as the first letter. So the females will be, we're going to choose 9, or we're going to choose 5 from this 9. So it's going to be from the given 9, we're going to choose 5. Okay, so 9 choose 5. Um, okay, so 9 choose 5. Okay, so let us write the formula then. So this is equal to, hopefully the formula will fit. Um, Excuse me for a while. 9 factorial. Okay, so that's going to be 9 factorial all over first 5 factorial. So we have 9 factorial all over 5 factorial times the quantity of 9 minus 5 quantity factorial. So this is going to give us similarly above what we have is 9 factorial all over 5 factorial times 9 minus 4. 9 minus 5 is 4, right? So this is going to be 4 factorial. Let's further expound. So 9 factorial, we're going to get the value of it 9 times 8 times 7 times 6 times 5 factorial. We'll stop there because we have a 5 factorial below. So what we're going to do is just to cancel it. And then we have 4 times 3 times 2. We don't need to write the 1. So 5 factorial is cancelled out, cancelled up. Um, we know 4 times 2 is 8, so we're going to cancel that. And then 3 can be cancelled with 6, so that 6 will become just 2. Sorry, 2. So 9 times 7 times 2. So what is 9 times 7? That's going to give us 63. 63 times 2 is going to give us 126. Okay, 63 times 2 is 126. So what we have here is 126. So meaning there are 126 ways for you to choose 5 females from a group of 9 females. Now we're going to consider males now. Let's denote that as M. And then we're going to choose 5 given the 6 males. So this is going to be a less number because there's only one male that is not chosen. So what we have is 6 males out of 5 males times the quantity of 6 minus 5 males. So that's actually 1. So let's continue. This is going to be 1, right? So it's okay not to write it anymore. So what we have is 6 times 5 factorial all over 5 factorial. So we cancel up 5 factorial, which leaves us 6. So meaning there are 6 ways for you to choose this 5 males rather. So what we're going to do by the multiplication principle, so we will write it by multiplication principle. Let's just denote it by MP, multiplication principle. What we're going to do is we will multiply um, 9 choose 5, which are the females, times the males, 6 choose 5. We got the values of them individually. So what we have is 126 times 6. 126 times 6 is going to give us 756. So there are 756 ways in order for us to create a 10-person committee composed of equal genders of male and females, both 5 males and females, and then given that there are 9 females and there are 6 males. Okay, so that's it for this video. Hopefully you got that now with the illustrated version. Hope you like and subscribe, and then so that you can see more of these. Okay, so thank you very much.